Go over here, darling. So what are some things that we need for an ecosystem? Raise your hand, please. Asa, give me something.
Abiotic and biotic material.
Okay, so an ecosystem has abiotic and biotic objects. Great. Abiotic means what? Give me an example of an abiotic thing, Jose. An abiotic thing, not biotic. Abiotic. Would you stop? Brayden, could you please give me an example of an abiotic thing? Dirt would be a great example. So dirt would be an example of abiotic. Jose, you want to give me an example of a biotic thing? What? Plants, yeah. Plants would be a great example of a biotic thing. And so in an ecosystem, you've got some things like dirt and you've got some things like plants. Are they separate or are they depending on each other?
Dependent.
Yeah, depending on each other. So these things depend on each other. If dirt is going to go ahead and be broken down and turn into good soil, it's got to go ahead and have plants. The roots go in there and break up the dirt. The plants die. They add organic material, and then you get really good soil. Plants also then live in that soil that is created. What are some other abiotic things that you need in an ecosystem? Brayden, give me one.
Water.
Water. Billy, give me another. We said dirt and water. What do you need to live? Need air. Plants need air. Animals need air. Organisms need air. Yeah, absolutely. Sunlight. You know, if we're talking about plants, that would be abiotic. That's not a lie. So an ecosystem has biotic and abiotic parts to it, and these objects are working together. They're interrelated, okay? They're like depending on another. It's a system. Many different parts kind of all doing the same thing. Well, they're not all doing the same thing, but they're churning out the same outcome. How do we feel about that? Awful? Not awful? Okay, let's go ahead and look at our spheres, because you just had a quiz on them. How many of you feel good? Give me a thumbs up. How many of you feel bad? Give me a thumbs down. How many of you are like, nah, maybe sideways? Okay, so then we'll go ahead and write a new quiz. I am going to grade those, and then tomorrow we can go over them. Tomorrow we're also going to check out our ecosystem. We're going to send you back there, and you're going to do your first check on your ecosystem and make some observations and draw some pictures. But right now what we're going to do is we're going to do a little deeper dive in one of our spheres called the geosphere. Turn with your pair share partners and talk about what the geosphere is. Ready, set, go. All right, what's the geosphere? Justin in the back, what's the geosphere? The earth, yeah. What part of the earth though? The ground part, the rocky part, right? Some might say it could be the skeleton of the planet, that everything else is grown or built on. What we're going to do today is we're going to do a deeper dive into the geosphere, and we're going to look in particular at the rock cycle. So at this time, you should have the sheet of paper that you picked up on the way in, and let's go ahead and put that in our TOC, table of contents. McKenna, would you mind moving that just a little bit this way so we can see the main screen? Thank you so much. Yes.
I need one of those.
Great. You should have picked it up on the way in.
No, table of contents.
Oh, then go over there and pick it up in the file folder. We have a pre-lab. It says, watch this video, and as you do so, complete the notes below. I'm going to do the very best that I can in helping you. Table of contents is the very first one. Okay. I'm going to do the very best that I can do to help you, but you need to pick up the slack and pay attention because we need to have time in our lab. And my last class, we did not have time. I'm not anticipating we're going to have time to finish our lab in this one. For sure, though, we want to get all the way through the front side, the second page of our lab. So we're going to get through the second page of our lab. We are not going to be able to get to the last page, but for sure we'll get the first 2 pages done. So let's check that pre-lab video out. We're going to do some pre-lab information. Now, when we are looking at this lab, it says we're going to learn about different rock types. We've got igneous, sedimentary, and metamorphic rock. There are 2 types of igneous rock we're going to look at. One is intrusive and one is extrusive. Can you please underline the IN in intrusive? Everybody underline the IN in intrusive. And then could you please underline the EX in extrusive? Underline the EX in extrusive. All right, let's go ahead and watch this video. I need you to please make sure that you are paying attention because this information is going to help you out when we are working through our lab.
Rocks are everywhere. They are large and small, heavy or light, porous or dense. But rocks in some shape or form can be found all over the planet. Different types of rocks are formed in different ways. There are 3 main types of rock: igneous, sedimentary, and metamorphic.
Have we heard about these rocks?
Igneous is a word that means fiery. Igneous rock is formed when magma or lava cools.
All right, here's what I need you to do. On your piece of paper, and I'll bring that up right here, where it says igneous rock formed when magma or lava cools. So we're going to be right here. Formed when magma or lava cools. That's what we're going to start with. That's the basis of igneous rock. Then what we're going to do is we're going to add to intrusive and write things here, and extrusive we're going to write there. And I already asked you to underline the IN and the EX. Well, get your head off the desk. Are we good here? Yes? Fantastic. Formed when magma or lava. Magma or lava, we got 2 different words there, and we're going to talk about the difference.
Sometimes magma cools slowly underneath the Earth's surface. This forms intrusive igneous rock.
All right, so what we're going to do is I'm going to get rid of these, and we're going to look at what we've got. Intrusive, notice the IN. That means that the magma has formed and cooled under the surface of the crust. So in the crust, IN, that means that the magma has cooled in the crust. So write that down under intrusive. Magma cooled in crust. Intrusive. So you've got this magma that's come up, and what's it done? It's forced itself between layers of rock. It's cooled inside the earth, IN, inside, and it's formed igneous intrusive rock. So an example would be granite. Please write down granite. That's an example. Granite is intrusive igneous rock.
Like granite. Other times, lava cools when it comes to the surface in a volcanic eruption. This forms extrusive igneous rock.
Okay, so extrusive igneous rock exits the crust. EX, exits the crust. Just like you exit the door to get out of our room, extrusive means the lava cools outside of the crust. So when lava leaves the crust, it's called lava. When it doesn't leave the crust, it's called magma. Extrusive rock is that melted magma that has left. It is now lava. It is cooled outside.
Cooled when it has exited.
Say again?
Cooled when it has exited.
When it has exited out. Cools when it exits. That's right. Think exit, EX. In for in the crust. X for exit the crust.
Some examples of extrusive igneous rock are tuff, obsidian, and pumice.
Okay, so you can write down any one of those. You can write pumice as an example. You can write obsidian, that's that beautiful glass rock. Pumice has a whole bunch of holes in it because when it releases, there's lots of gas that lets go really quickly and gets out of the rock. And the gas has bubbles, so the gas comes out in bubbles and then the rock cools really quickly and you can see all those holes. So obsidian or pumice.
Or tough.
Or two.
Igneous rocks make up about 95% of the Earth's crust.
Let's write down 95%. So igneous rocks are 95% of all the rocks on our planet. 95%.
The next type of rock is sedimentary rock. Sediment is small particles of sand, mud, and
Okay, so sediment, what I want you to do is write down small particles of sand and mud. Or sand or mud. Small particles, that's sediment. Do we have sediment down here? Do we not have sediment? Oh, we just have sedimentary rock. So then sediment is small particles of sand and mud. Then what do you think we do with those small particles in order to make them a rock? That's right, we do that. So let's go ahead and see them do that.
organic material that settle to the bottom of water or land areas, often lakes or oceans.
Okay, pause. Why is this river brown?
Because of all the mud that is picking.
Yeah, so there's a lot of sediment being carried away. Imagine the fields and, the streams and the mountains that are being broken down, and streams are really good as ways to carry those into different locations.
Sedimentary rocks are formed when sediment accumulates over time into...
Okay, here's what I want you to write. Sedimentary rocks are formed. You don't have to write are formed, but I want you to, what's another word for accumulates? Gathered? So sediments are gathered over time in layers. Okay, sediments are gathered over time in layers. Sediment gathers over time in layers. And you can see these beautiful layers right here. They're horizontal. That's that law of original horizontality, saying that sediment should, layer up like this. And you can see things get trapped in the layers. Different rocks, animals, sticks, stones.
So that would be yes for the question.
So the question, Asa,
deposits that form layers.
can we find fossilized
These
rocks?
layers become
we have to
squeezed
add
and
this.
compressed.
So the layers are squeezed and compressed. Layers are squeezed and compressed. Now, there's different, we can also cement them together, and tomorrow, hopefully we'll go ahead and get started on some notes where I'll give you some rock information about compaction or cementation. Do you know what cement is? Yeah, same thing, right? You can cement tiny particles together. And maybe we'll go ahead and make our own little sedimentary rock tomorrow.
Pressed over time until they consolidate into a rock.
Isn't that gorgeous? My
Sedimentary
goodness.
rocks are the types of rocks in which fossils may be found.
So the question, can fossils be found in sedimentary rocks? Yes. They're the only rocks that fossils can be found in pristine conditions. Because if something dies in the ocean and it settles to the bottom, it's just going to have other layers on top of it, and it's going to preserve it. If you take this rock and you melt it down into magma, are we going to see those fossils anymore?
No.
No, they're going to be totally destroyed. They're going to be totally destroyed.
Since the process of forming sedimentary rocks can preserve plant and animal remains that are deposited into the sediment layers.
Wouldn't it be great to have like kitchen counters like that?
Some examples of sedimentary rock are limestone,
Okay, let's go ahead and write down limestone. Limestone, when it is heated, it'll change into marble. Have you ever heard of marble? Beautiful.
Marble countertop.
Shale, when it's heated, will turn into slate. And they also have sandstone, and when that's heated, it'll turn into a very hard rock called quartzite. But just write down an example of a sedimentary rock. And limestone is a great one, because we live like our bedrock here is all limestone.
shale, and sandstone. The third type of rock is metamorphic rock.
All right, has anybody ever heard of morphing into something else?
Yeah.
Have you ever, when you were in grade school, made butterflies out of caterpillars?
Yep.
And there's that metamorphosis where you change into something? That means this rock changes from one kind of rock into another. It's morphing or changing into something. So if you want to underline morph and over that or above that, write the word change. Go ahead and do that so that you can make that connection for yourself. It's morphing from one rock to another. For example, limestone will morph into marble.
The word metamorph means to change form, and
That's
metamorphic
marble.
rock is rock that has been changed by extreme heat and pressure.
Okay, write that down. So, rock that has been changed by extreme heat and pressure. And I mean, you have to bake this rock or have it be like in the bottom of a mountain, lots of layers, pushing down over long periods of time. It's not just like, let me squeeze some sediment together. Oh, that's a metamorphic rock. No, it's not. That just means like if you're at the beach and you've got sand and it's wet and you hold it together and it kind of holds its shape, that's a sedimentary, the start of a sedimentary rock. This is something that you can't get the sediment, the same sediment back out. It has been chemically and physically altered through that heating process.
Sedimentary rock, igneous rock, or even other metamorphic rocks can be changed by heat and pressure into new kinds of rock. Metamorphic rocks can be formed by being deep under the earth where pressure and temperatures are high, or when rock near the surface is heated up.
Okay, so I want to show you this really quick. So imagine that this is all sedimentary rock, and you've got this intrusion of magma that comes up, and what it's done is it's baked this rock that surrounds it, and it changes it into something else. So let's say this is no longer sandstone, now it's been baked into quartzite. So you've got quartzite right here, you'd have granite here, and then you'd have quartzite through here, and then this would still be like sandstone.
By the movement of tectonic plates or magma. Different types of rocks become different types of metamorphic rock when exposed to heat and pressure. For example, shale becomes slate. Sandstone becomes quartzite. And limestone becomes marble. Rocks are slowly but constantly changing in something known as the rock cycle.
All right, so at the bottom it says, hey, could you please make sure that you are sketching a diagram of the rock cycle? In doing so, let's try to see what is happening during the process. Include the following terms: magma, igneous rock, erosion, sediment, sedimentary rock, tectonic activity, heat pressure, metamorphic rock, and melt. So I'm going to give you a minute to write this down. These things are kind of like your nouns, right? Metamorphic, sedimentary, igneous, and magma. Down on the bottom, William, you're writing this down on the bottom. Make a box, okay? So make one box that says igneous, make a box that says sedimentary, make a box that says metamorphic, make a box that says magma, and then include the arrows that we have here. If I wanted magma to turn into igneous rock, what would have this arrow represent? Turn with your pair share partners. It's melted rock, and I want it to turn into igneous rock. What has to happen here with that magma? Turn and talk that out. Turn and talk that out. Ready, set, go. What should be here?
The volcano.
No, not the volcano. What should be here? What's going to happen with that magma?
Cool.
It's going to cool. So the magma cools. Write that down on that. It cools. Yes, I'm sure there's a volcano involved, but Asa, I'm keeping it simple. Now, what if this igneous rock is turning into magma? What has to happen to the igneous rock in order for it to turn into magma?
Melted.
Melts. So the arrows are the processes, and that gives us the outcome, which are the rocks. You understand what we're doing? If I want this sedimentary rock to go ahead and turn into metamorphic rock, with your pair share partner, turn and talk that out. What has to happen to that sedimentary rock? Ready, set, go.
Heat and pressure.
What happens? No, not you, Asa. Yep.
It heats up and gets compressed too.
Yeah, you have extreme heat and pressure, H and P, extreme heat and pressure. You see what we're doing? What if I want igneous rock to turn into metamorphic rock? What do I have to do? Extreme heat and pressure. Extreme H and P, heat and pressure. You got me? Lauren, what if I want metamorphic rock to turn into magma? What does this arrow need to do? Yeah, but how much? A lot, until what happens to this rock? Melts. Metamorphic rock melts and turns into magma. Do you see what we're doing? Okay. Let's go ahead and look at the lab that you picked up. Let's go ahead and turn that page, please. So then what you're going to have, it says materials per group. You've got 4 different colored starbursts. I have listened to so many complaining, put your phone away, through my first hour class, all about like, these starbursts are old, they don't break apart. I'm sorry, the starbursts are going to be difficult for you to break apart, but we're using starbursts. Make sure that you don't eat anything in the lab area, okay? So you're going to have 4 different colored starbursts. I need you to break up each starburst into 4 pieces. All right, 4 pieces. That's not going to be hard. Use the scissors, and if you want, push down in the middle. Try to break them apart. We just need 4 pieces of each starburst into 4 pieces. Make sure that you put your goggles on. I will have mine on the entire time as a modeling for you, because these things have been flying around, and all I need is for your eyes to let go with, because you don't have your goggles on. Now, for those of you that have glasses, and you're like, I don't need them, I have glasses. Yes, I will have glasses on too, but I want you to know that I've got these safety glasses so that they fit right over your glasses. Easy peasy, no worries. So don't look at me and say, I don't need them. Yes, you do. The first thing says directions. Take your 4 colored starbursts, cut them into as many small pieces as you can. I'm just saying 4 is fine. And then you're going to go ahead and make a pile of them. Then you're going to draw and color that picture of that pile of individual pieces. Then you're going to go ahead with your pair share partners and say, okay, which one in this column have we just created? Okay, have we created igneous rock, sediments, sedimentary rock, metamorphic rock, or magma, based on what we did in the video? Do you understand what you're doing? You should get all the way through this one page. When do we get out of here? 24? And we have like a little under 20 minutes, so we're going to go ahead and break them apart and see what we can do. Now, when you get all the way down and make sure that everybody's participating, we'll then go ahead and see if we have time to move on. I don't think we will. The book I've not given you because people were smashing my books and breaking the bindings, so we're not doing that this year. Just go ahead and use heat. Heat up your hands and then press down for the heat and pressure on that. Good? One thing else I want to show you is if we get to the melting part, these are what's called crucible tongs. Notice how there's that little bump in the middle there so that you can lift this little metal tray as it's bubbling hot magma and take it off of the heating plate and lay it on your table. You're not going to pick them up like this. You're not going to scream. It's hot, melted candy. It will burn your skin. So again, 2 hands, gently squeeze it, pick it up off, and put it down there. Probably are not going to get through that today. Goggles, first things first, and then the next thing I want you to do is on the baggie that I put on your table, write the class period and put which table number you're on, because that way at the end I can collect them and we can give them back to you tomorrow. We're going to go ahead and start with Lauren in the back. You're number 1, 2, William 3, 4, 5, 6, Justin, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. So 1s go to 1s, 2s go to 2s. First things first, goggles, and then write your name, please, or rather the class period and what table you're at. Everybody get involved.
Hello, people at home. Goodbye, people at home.